Consider the following quadratic function, y equals x squared plus 10x plus 16. Step 1 of 5, rewrite the given quadratic function in the form y equals a times x minus h, that quantity squared, plus k. So in this problem, I actually have to complete the square in order to do the problem. Well, we're going to do that by going ahead and looking at y equals x squared plus 10x plus 16. And I'm going to go through the process of completing the square just like we did in the previous module. So I am going to go ahead and move the constant term. So I'm going to subtract 16 from both sides. That's going to give me y minus 16 equals x squared plus 10x. And then remember, to complete the square, you're going to take half of 10, which will give me 5. And then I'm going to do 5 squared, which is going to be 25. And that's what I'm actually adding to both sides. So y minus 16 plus 25 equals x squared plus 10x plus 25. Simplifying things a little bit over here on the left, negative 16 plus 25 is y plus 9 equals, and then I'm going to factor x squared plus 10x plus 25 is going to factor into x plus 5, that quantity squared. Remember, that's our factor. And now, to put it in vertex form, I'm going to actually isolate the y term, which is a step we didn't do previously, but we're going to subtract 9 from both sides. Y equals x plus 5, that quantity squared, minus 9. That's what we're going to write in this box right here. X plus 5 squared minus 9. Step 2, find the vertex of this function. So I went ahead and transferred over the vertex form of the function. Y equals x plus 5, the quantity squared, minus 9. So our vertex is hk, which in this case is negative 5, negative 9. Step 3, find the x-intercepts, if any, of this function. Express your answer as ordered pairs. We'll go ahead and write the vertex form. Y equals x plus 5 squared minus 9. And then we can determine which equation it's easier to solve our x-intercepts for. So remember, when we cross the x-axis, y is equal to 0. And we can do this on either case, it doesn't matter. We'll just go ahead and use our vertex form since that's what we started with. So that gives me 0 equals x plus 5 squared minus 9. And so then I'm going to add 9 to both sides. 9 equals x plus 5 squared. This is using isolating the squared term, so I'm going to take the square root of both sides. That is x plus 5 equals plus or minus the square root of 9. Subtract 5. X equals negative 5 plus or minus 3. So looking at our solutions, it looks like we're going to have 2. And let's see, it's negative 5 plus 3. And negative 5 minus 3, which gives me negative 2 and negative 8. So my x-intercepts are negative 2, 0, and negative 8, 0. Step 4, find the y-intercept. Express your answer as an ordered pair. I am going to talk about something here. When we have our equation in y equals ax squared plus bx plus c form, our y-intercept is our c value. So in this case, it's 16. So remember, though, when you figure that out, you're plugging x equals 0 in. That's how you find your y-intercept. So your ordered pair is 0, 16. Step 5 is to graph the function. So we have where our vertex is negative 5, negative 9. Our x-intercepts were at negative 2, 0, and negative 8, 0. And then we have our y-intercept at 0, 16. I don't think I'm going to be able to graph 0, 16 looking at this particular coordinate plane, but I can go ahead and graph negative 5, negative 9, which is my vertex. So there's where that point is. And then negative 2, 0. It's right there. And negative 8, 0 is right there. And so I've got enough to graph my function.